Section 2.4, we're going to do a little bit more on slope. We're going to talk about the slopes and equations of parallel and perpendicular lines, and a little more about interpreting slope as an average rate of change. So parallel lines, you've probably heard of this as being two lines that cannot cross, or two lines that never intersect. Those are what we call parallel lines. So way to kind of think about it is if we have two non-vertical lines are parallel, they have the same slope, and vice versa. So this statement goes both ways. If two non-vertical lines have the same slope, they are parallel. So if we just happen to have two lines and we assess their slopes, so both these are going to have a slope of 2/3. We know that these lines have to be parallel. Get an extra arm parallel. There we go. So parallel lines, like I said, we know we're going to have the same slope, and two silent lines with the same slope are going to be parallel. So that's a if and only if statement. It goes both ways. So two distinct lines, if we have two distinct vertical lines, both have undefined slopes, then we know they're going to be parallel. So if I have two vertical lines, they're also parallel. So essentially all vertical lines are parallel to each other. Okay. So it's mostly the second statement here is the one we're really going to use going forward. So we want to write an equation of a line passing through the point -2, 5 and parallel to the line whose equation is y equals 3x plus 1. We want to express the equation in point slope form and slope intercept form. So we want a line parallel to 3x plus 1. So this line that we're looking for, because parallel lines have the same slope, this line will also have a slope of m equals 3. We are already told an ordered pair, so we pretty much have all the information we need to find this line. So we have y minus my y1, which is 5, is equal to my slope, which we said is 3 because it has to be parallel to this line, and then times x minus x1, which is my -2. So we have y minus 5 equals 3 times x plus 2. So we fit the first part of this. This is the point slope form. Now if we start solving for y, if I distribute my 3, I end up with 3x plus 6. And then if I add my 5 to both sides, I get y is equal to 3x plus 11. So we see these lines have the same slope, they just have different y-intercepts. But this will be slope-intercept form. So there are some problems that you may face, especially coming into calculus, where you do need to figure out a parallel line, or you may have to find a perpendicular line, which is why we're going to be covering this. So we now know a line that is going to be parallel to this line in case we needed it. So your first problem on your worksheet is we want to write the equation of a line passing the point 6, -4, and parallel to the line whose equation is 4x minus 3y equals 36. So we need to figure out what the slope of that line is, and then express the equation in point slope form and slope intercept form. All right, so we need the slope of this line before I can even do anything. So that line is 4x minus 3y equals 36. So if I just solve for y, I'm just going to subtract x from the other side. We're going to have negative 4x plus 36. And if I divide everything by -3, we get y is equal to positive 4/3 x minus 12. So I see my slope is 4/3. So now the parallel line, we know the slope is going to be 4/3, and we know the point x1, y1. We have one point that we know that line is going to pass through, which is 6, -4. So just take y minus y1, so y minus -4 equals m 4/3 times x minus x1, and x1 is going to be 6. So y plus 4 equals 4/3 x minus 6. And there is point slope form. Now, if we keep going for it with it and we just start solving for y, we're going to get y plus 4 is equal to 3/4 x minus 6 times 4/3, not 3/4, 4/3. Y plus 4 is going to be equal to 4/3 x. So this is going to be 6 divided by 3 is going to be 2. So this is just going to be -8. Now we subtract 4 from both sides. We get that y is equal to 4/3 x minus 12. So silly enough, we actually just got the same line back. Still, technically, it's a parallel line. So technically, two lines can be parallel if it's the same line. There's some technicality there. We usually like them to be distinct. All right, so two non-vertical lines are perpendicular when the product of their slopes is -1. So there's another way to say this, which is so the slope of perpendicular lines the slope of one is the negative reciprocal of the other. Meaning one is going to be AB and the other is negative BA. So that's where we get the product. It's going to be -1 because if I take AB and I times it to negative BA, that's going to give me -1. So if the product of two lines or the slope of two lines is -1, then we know those lines are going to be perpendicular. So it's a way to check. A horizontal line having 0 slope is perpendicular to a vertical line having an undefined slope. So all horizontal lines are perpendicular to vertical lines and vice versa. So we want to find the slope of any line that's perpendicular to a line whose equation is x plus 3y minus 12 equals 0. So I need to know the slope of the line so I can find the slope of the next line. So this line, we just need to solve for y so we can get that slope. So if I do that, we can just subtract 3y from both sides. So we would get x minus 12 is equal to negative 3y. And then we can divide by negative 3. And what we'll get is negative 3x plus 4 equals y. So I need the negative reciprocal of the slope, negative 3. So negative 3 is just, think of that as negative 3 over 1. So the reciprocal, or the negative reciprocal, would have to be positive 1/3. So the slope of the perpendicular line is 1/3. So that's all we were asked for, is just find the slope of the perpendicular line. All right, so what am I going to ask you to do? I want you to find the equation of a line passing through the point 6, negative 4, and is perpendicular to the line whose equation is 4x minus 3y equals 36, and express the equation in point slope form and slope intercept form. So we just did find the slope of this line earlier in worksheet number 1. So go back to that question, and you don't have to do it again, just pull that slope. Okay, so 4x minus 3y equals 36. We wrote that as y equals 4/3 x minus 12. So that means the slope is 4/3. The slope of the perpendicular line there's some special letters missing there. Perpendicular line is going to be negative 3/4 because it has to be the negative reciprocal. So my perpendicular line is y. So remember, this is x1, y1. So this is going to be y minus negative 4 equals the slope of the perpendicular line, which is negative 3/4, times x minus x1, which is my 6. So we get y plus 4 equals negative 3/4 x minus 6. And there's my point slope form. Now we just keep solving for y to get slope intercept form. So y plus 4, if I distribute that, that is going to be negative 3/4 x minus, so the 3, plus, it'll be plus then, 3 and 6, that's going to be 18 over 4. Making sure I'm getting what I think I'm getting here. 2, 3, yeah. So we're going to get y plus 4 equals 3/4 x plus 9 over 2. We subtract the 4 from both sides. So go back here. We're going to end up with y plus 4 equals negative 3/4 x plus 9 over 2 minus 4, which is going to be minus 8 over 2. So we just moved that 4, so I don't need it there anymore. So that's just y. So we get y is equal to negative 3/4 x plus 1/2. So we're going to look at slope as a rate of change. So slope is defined as the ratio of a change in y to the corresponding change in x. And we did a little bit of this in 2.3. So we're going to expand on this. So we were looking at our slope as a ratio of change in y over change in x. It describes how fast y is changing in respect to x. For a linear equation, slope may be interpreted as a rate of change of the dependent variable per unit change in the independent variable. So what we mean by that is in 2000, 11.9% of young adults lived with their parents. In 2017, 22.0% of young adults lived with their parents. Use this information to find the slope of the linear function representing young adults living with their parents. Express the slope correct to 2 decimal places and describe what it represents. So we want a function representing young adults living with their parents. So that means that f of x is going to be the young adults, or the percentage of them. So we say percentage of young adults. Adults living with their parents, we'll just write young adults to save on space here. And then x would have to represent year or time. So we want to just look for the slope and express it to 2 decimal places correctly. So remember, y's then are just the percentage of young adults. So we have an ordered pair here where we have the year 2000, that's my x. And then the y goes with it as that percentage of young adults living with their parents, so 11.9%. And that's going to be my y. Then I have another pair of points, which is the year 2017, which has to be my x because x is years. And then my y is percentage of young adults live with their parents, so that's 22.0. And that's going to be my y2. So my slope is going to be 22.0 minus 11.9 divided by 2017 minus 2000. Let's make a calculator out because we're going to have some, here in a second. So this difference here is just 10.1 divided by 17. So 10.1 divided by 17 is going to be, we need to describe this to 2 decimal places, 0.63. So remember, this is representing a change in y over a change in x. So y is the percentage. So this is going to be 0.63% of young adults living at home per year. So another way of looking at this is, which every time we go up by another year, another 0.63% of young adults are going to be living at home. So for each additional year, the percentage of young adults living at home increases by 0.63%. Okay, so your worksheet problem is going to be in 1988. It was estimated that 3,723,520 square kilometers of rainforest were left in Brazil. There was estimated to be about 3,290,125 square kilometers left in 2020. Use this information to find the slope of the linear function representing the area of rainforest in Brazil that is still living rainforest. I think it's supposed to be living in Brazil. Express the slope correct to 2 decimal places and describe what it represents. So describe what the slope is representing for us. All right, so we see here the slope of the linear function is supposed to be, oh, sorry, not the slope of the linear function, I went a little too far. The linear function is supposed to be representing area of rainforest. So fx is area. And x will then have to represent that time component. So we have as xy pairs in 1988, we know what the rainforest was, or how many, the area of the rainforest. So we have a year in area. And then 2020, we also have a year in an area. So my slope is going to be, we'll make this x1, y1, x2, y2. So we should have seen a negative slope here because we had a decrease in the amount of rainforest. So I'm just going to write the numbers down opposed to trying to say all those millions of miles of square kilometers of rainforest again. So if we put this year here, this area goes along with the year of 2020, and this area here goes along with the year of 1988. So let me get that. So we had 3,290,125 kilometers of rainforest, and we're subtracting 3,723,520 kilometers, leaving us with, we've lost 433,395 kilometers of rainforest over oops. We can do that one more time. Over 32 years. So negative 433,395 divided by 32. 2 decimal places. So that's going to give me a negative 13,543.59. So remember, this was representing the area in square kilometers, and this is representing the year. So this is a loss of 13,543,000, or sorry, 13,543.59 square kilometers of rainforest per year. So this is how much we're losing. So we lose 13,543.59 square kilometers of rainforest every year. So average rate of change, like I said, it's when we talk about slope, usually when we talk about a linear equation, it's just a rate of change. Now, when you have any kind of function that's not a linear equation, then we change it to an average rate of change. So we're going to let x1 f x1, x2 f of x2 be two distinct points on the graph, which we see here, of a function. The average rate of change, so we're not looking at, like there's a bunch of different changes here. Like the slope is different as this equation goes along. So we're getting different slopes. So we look at different points. What we're looking for is on average between here and here, what was the change? And we call this line that we're going to make, it's essentially that goes through these 2 points, is a secant line. So this is something that you are going to use going into calculus. So an average rate of change here would be f of x2 minus f of x1 over x2 minus x1. Because remember, this is just y1, y2. So my slope formula really hasn't changed much. It's just we're using f of x now. So we want to find the average rate of change for fx equals x cubed from x1 is -2 and x2 is 0. So my slope, remember, is f of x2 minus f of x1. Sorry, that cube there threw me off and I put things in a superscript. I need a subscript for x2 minus x1. So this is going to represent my x2 is 0, so I need to figure out what f of 0 is minus f of x1, so f of -2, divided by x2 0 minus x1, which is -2. So if I go back here, f of 0 is just 0 cubed minus, I have f of -2, so that's going to be -2 cubed. And then we have 0, we can say 0 plus 2 if we change that. So 0 cubed is just 0. -3 cubed, remember that's -3, or -3 cubed, -2 cubed is -2 times -2 times -2. That's going to be -8. So we're going to be left with 8 over 2. Make sure I got this all right. Yeah, 8 over 2. So this is just going to be a rate of change of 4. So average rate of change from x1 equals -2 to x2 equals 0 is going to be 4. Okay, so you're going to do this again. So the formula for the distance traveled by an object in free fall on Earth is st, which is equal to 4.9 t squared, where t is the time in seconds and s is the distance traveled in meters. We want to find the average rate of change from a t3 to t6. So from 3 seconds to 6 seconds. And how can we interpret this average rate of change? So the function value is the part that's on top. So we're going from s of t2 minus s of t1. And then the bottom is t1 to t2 to t1 because t is my independent variable. So we have 4.9. Formula for the distance travel. Okay, I was going to say, is it distance travel? How close it is? 4.9. And then we have t2. And t2 is my 6, so that is going to be 6 squared. Minus 4.9, and then we have t1, which is my 3, so that's going to be 3 squared. Over t2, which is 6, minus t1, which is 3. So let me just get my numbers here. So that means that we are going to have 4.9 times 6 squared, which is going to be 176.4. And then 4.9 times 3 squared is going to be 44.1. And then we're divided by 3. So we got 176.4 minus 44.1. That is going to be 132.3 divided by 3, which is going to give me 44.1. So we did get a number back there. That's fine. So how can we interpret this average rate of change? So this is representing my distance traveled in meters. And this is my time in seconds. So what we have is average rate of change from 3 seconds to 6 seconds is going to be 44.1 meters per second. So we found a speed.